This video looks at some questions to do with chemical bonding and structures that are found on the IGCSE chemistry syllabus. When you're doing these questions, I recommend actually doing them first, having a periodic table in front of you, but doing the questions first and then playing the video back to see if you get the questions right. So, on with the first one. This came from quite an old paper actually, probably back in 2006 or so, and they give you quite a lot of information at the top, and it's to do with carbon dioxide and silicon dioxide. There's a lot of information up here. Carbon dioxide sublimes at minus 78 degrees C, and silicon dioxide melts at 1728. So melting is obviously when a substance turns from a solid to a liquid. Sublimes is something a little bit more special. It's when a solid turns into a gas without going through that intermediate liquid phase, and that's actually the first question. And you might expect the chemistry of carbon dioxide and silicon dioxide to be very similar. They're both oxides. They're both oxides of an element found in group 4, a non-metal oxide. And that's actually the answer to a question down here. Suggest why carbon dioxide and silicon dioxide have similar properties. Well, they are oxides of two group 4 non-metals. Now, they're both in group 4, as I've said here, which tells you, if you look at your periodic table, you'll find them in group 4, that both of them have 4 electrons in their outer shell. So you might expect them to have very similar chemistry. They're both oxides of 2 group 4 non-metals, and because they are non-metals bonding to oxygen, you'd expect the bonding to be covalent. Both of them would have covalent bonding, and that's because they're compounds only containing non-metals. So very similar. But look at the difference. Carbon dioxide sublimes at minus 78 degrees C, so it's a gas at room temperature, and yet silicon dioxide is a solid at room temperature and won't melt until 1728 degrees Celsius. Now, what does that tell you about the structure of silicon dioxide? Well, it must be a giant covalent structure. And you know that because the melting point is so incredibly high. And the reason it would have a high melting point is because you'd have a giant network of atoms all covalently bonded to each other. So here are my atoms. Very similar to diamond, except you'd have silicon atoms with oxygen atoms in between them. But in order to melt the substance, you'd have to break a vast number, millions in fact, covalent bonds, and that requires a huge amount of energy. Carbon dioxide is not a giant covalent structure, it's a simple molecular substance. So no covalent bonds will be broken when the carbon dioxide sublimes. We would just be overcoming the weak forces that are between the molecules, the weak intermolecular forces. So carbon dioxide turns into a gas at a very, very low temperature. Now this is a fairly common question. Draw the cross and dot diagram to show the bonding in water. Now water is, I've got the wrong function on, is H 2O. And it sounds really obvious to say it, but that means there are 2 hydrogen atoms for every 1 oxygen. The number of times I've picked up A-level scripts with this on it, and you'll see that a student has drawn 2 oxygens and 1 hydrogen. Maybe that says something worrying about my teaching. I won't beat myself up too much about this at this point. So we've got 2 hydrogens and 1 oxygen. Now get your periodic table out. You can see that oxygen is in which group? It's in group 6. Now that means oxygen has 6 electrons in its outer shell. So I'm not going to bother drawing the circles for the electron arrangements. I'm just drawing O, and then there are my 6 electrons. And all atoms are really aiming to have a full outer shell of electrons. And in oxygen's case, it would like to have 8 electrons. Hydrogen is in group 1, which means hydrogen only has 1 electron in its outer shell. If hydrogen was to have a full outer shell, it would have 2 electrons in the outer shell. So what the hydrogen can do is it can share a pair of electrons with the oxygen. So now the hydrogen has a full outer shell, and the oxygen has a full outer shell. So here we have 2 covalent bonds, and you should know the definition of covalent bond, okay, which is nicely summarised initially by this little phrase here, SPOE, shared pair of electrons, and these electrons are attracted to the 2 nuclei of the atoms bonded together. Likewise, this pair of electrons are attracted to these 2 nuclei, and the nuclei are attracted to the electrons because the electrons are negative and each nucleus contains protons, so that's positive. Now in this question, they start off by talking about a reaction between magnesium and fluorine. Now that must be quite a feisty reaction because fluorine is incredibly reactive, and as you know from reacting magnesium in air, when it burns with a bright white light, magnesium's not shy either. So they've told you it makes an ionic compound, but you should know that anyway because you've got a metal bonding with a non-metal. And very generously they've also given you some electronic structures. And you can see that magnesium has 2 electrons in its outer shell. It's dying to have a full outer shell. It would love a full outer shell. So it gets rid of those 2 outer electrons to form magnesium 2+. Magnesium 2+ would be 2,8. Now those 2 electrons have to go somewhere, and they will be picked up by the fluorine. Now the fluorine will then become 2,8 itself. Okay, it can't become 2,9 because otherwise that outer shell would be over full. So we've still got an electron to house, so we need another fluorine to do that. And therefore the fluorine, each fluorine has gained 1 electron, so it becomes F-, and it becomes fluoride. Okay, so in your answer you have to say that the magnesium loses 2 electrons. We have 2 fluorines, and each one of them picks up 1 electron to gain a full outer shell there and becomes F-. Now, the next question asks us about oxidation and reduction, and for this we need to remember either oil rig or what I prefer, Leo Ger. Okay, oil rig, oxidation is loss, reduction is gain. And I realise amateurishly I've written Leo Ger out. I've used eyes. Okay, it's much better with ease, which is why I prefer Leo Ger. Lose electrons, oxidation, gain electrons, reduction. So, which element has been oxidised? Well, which element has lost electrons? So the magnesium has lost so the magnesium is oxidised, and the fluorine has gained an electron, so that's been reduced. Okay, and we've already answered part C1 up here. We've got Mg 2 plus and F 1 minus, and in the compound our formula is going to be MgF2 because the overall compound is neutral, so we'll need 2 fluorines, or 2 fluorides should I say, to cancel out the 2 plus. Now this question is obviously about nylon, which is a polymer made, as you should hopefully know, by condensation polymerization. That's usually covered towards the end of the IGCSE course. Now you don't actually need to know much about nylon in order to answer this question, because all the clues are in the question. It tells you it has a simple molecular structure. And if something has a simple molecular structure, already in the exam you should be predicting, well, what are other low molecular or simple molecular structures I know? Well, you should be able to think of water, that's a simple molecular structure. Carbon dioxide, that's simple molecular. Ammonia, and all these substances have low melting and boiling points, and they're all made from non-metals that are covalently bonded together. And well, let's have a look and let's see what the question's asked us for. So the question has actually asked us for the melting point. You should have really been able to predict what the question was going to ask you from just this part here. So nylon has we've already answered it, a low melting point. Okay, now this is because there are, if it's going to have a low melting point, there's a good chance the forces are going to be weak. Okay, and it's between what makes up the structure. You've got a choice here between molecules and ions. Now bearing in mind the question has already told you it's molecular, the answer is obviously going to be molecules. Okay, it's not going to be any ions because it's a molecular structure. So here's one nylon molecule, here's another nylon molecule, and the forces between them are particularly weak. So when we apply a bit of heat to them, the molecules are easily able to move further apart, and so they've melted. You'll note that we've not chopped the molecule up at all. The molecule is still the same size if you give me a little bit of artistic license. So we haven't broken any covalent bonds. The only time you'd break covalent bonds when melting a substance is when you have giant covalent structures like diamond or graphite. And I'm going to pause this half